Parkinson's disease. What is it? Before I immigrated, I saw my grandfather and he was fine. But when I visited my relatives again in 2009, I saw what Parkinson's has truly done. He had severe tremors and muscle rigidness to the point where he had to rest every 10 minutes. Couldn't play games with him as much, could barely go outside as much as he had to sit down a lot. 10 years later, it still makes me sad Skyping him as it gets worse. So once this opportunity came up, I knew I had to research Parkinson's to educate myself and give me inspiration for a future career in science, and who knows, maybe I'll find a cure for Parkinson's disease as well. Parkinson's disease is a neurodegenerative disorder that affects the substantia nigra region of the brain and can help with dopamine distribution. Specifically, Parkinson's disease affects the neurotransmitters that help create dopamine. This can cause motor dysfunctions such as muscle rigidness, tremors, anxiety, speech and swallowing issues, apathy, depression, or even hallucinations and delusions. Research on Parkinson's disease includes the LRRK2 gene and the SNCA gene, but LRRK2 is researched more and has been shown to be related to late-onset Parkinson's disease. Another internal cause is mitochondrial defects, which occur during aging or can be a genetic defect. This alters how dopamine-producing cells act due to a lack of energy within the cells, making less healthy brains susceptible to defective mitochondria, and those people are more prone to Parkinson's disease. Exterior causes can vary from exposure to pesticides, which have been directly linked to Parkinson's disease, and other chemicals. Even head trauma can cause Parkinson's disease as it does damage the brain by disrupting neurotransmitters. Parkinson's was primarily cataloged in an ancient Indian medical system. In Western medical literature, it was described as shaking palsy in AD 175. It was not until 1817 that a detailed essay was written and was published by James Parkinson. Over a century later, in 1960, significant chemical differences in brains of Parkinson's patients allowed for its identification. In 1960, levodopa was introduced and administered to treat symptoms of Parkinson's disease. Common with Parkinson's disease is monoamine oxidase or MAO, levodopa, and carbidopa. Monoamine oxidase can come in two types, salicyline and rosagline, which helps decrease muscle rigidity and improve motor skills by replenishing dopamine or mimicking the action of dopamine. Levodopa is a pill taken to increase dopamine levels because it is synthesized within the brain that is absorbed by the small intestine so that it travels through the bloodstream into the brain. Carbidopa is almost always taken in combination with levodopa, which helps reduce nausea symptoms as well as vomiting and is an enhancer for levodopa, offering a smaller dosage with better results. Since clinical trials cannot be taken to study Parkinson's, instead mice are induced with Parkinson's-like symptoms to test medication and make different mouse models such as knockout mice to find genetic markers with different mice or different pathways to dopamine loss. For example, research targeting alpha-synuclein, which is one of the main causes of PD, researchers has found that the loss of alpha-synuclein structures led to the accumulation of that protein's monomer that resulted in degeneration of dopaminergic neurons, specifically within the substantia nigra, which is the most commonly affected region of the brain, which is most known to trigger progressive loss of motor functions. What the study shows in the mice is that a healthy alpha-synuclein structure is needed to maintaining a healthy brain and preventing Parkinson's. This can allow people to act more quickly in preventing or even delaying the onset of Parkinson's. It can be a marker for diagnosis of Parkinson's. And by visualizing the LRRK2 changes, can help identify disease mechanics and ultimately promote future therapeutic interventions.